Hello, good evening to you all. Am I audible?
Yes, sir.
Yeah,
Audible.
yeah. Okay. Yeah, just I'm waiting for 2 more minutes. Then we'll start. Uh, okay. Uh, Hello. Am I audible? Are you getting me now? Hello, Asim. Okay, okay, okay. Myself, Subrata Kumar Maiti. This is the subject on hydrogen energy production, storage, and transportation and safety. Okay. So far, so on, we have studied productions, and now we are on the stage. We are studying some part of the storage systems, and today's also we will discuss some part of storage systems as well as some part of transportations. Okay, today I will do something different. That means I will start with first numerical, I mean MCQ questions. Okay, Then we'll go one by one slide for better understanding. Okay. So I am coming to the questions, and one class probably I will take in the last classes. I will show you the electrolyzer cell and fuel cell setup such that it can be a little visualizations to you, such that how does it look. And 1 minute, one student is waiting, I think. uh, in the last class I will show you a bit introductions part of the fuel cell and electrolyzer, how it operates, how it look like. Okay. And what is the major component we should take care during the design, during the system assemble time. Okay. Okay. Actually, the major part of the hydrogen productions, that is the all over the world, and the government is trying to focus, that is the electrolyzer part. So we should have some basic understanding about the electrolyzer, what are the major component, and how we will assemble this water electrolyzer part, and how we calculate, how we measure the produce hydrogen in a lab scale, I mean. Okay. And what are the material they uses. As you know, the different type of the water electrolyzer is there. First and foremost is the proton exchange membrane water electrolyzer, I mean cation exchange membrane water electrolyzer. Then now the trending is the anion exchange membrane electrolyzer, because they have some good advantages over proton exchange membrane water electrolyzer. I mean, there it may water can be used a bit lower quality water can be used, as well as some electrode material is also less costly material in anion exchange membrane water electrolyzer. That's why now in India, like different companies, starting from Adani, Reliance, all of the companies are looking for this anion exchange membrane water electrolyzer. This is not yet commercialized fully, but proton exchange membrane, you can say, it is fully commercialized. So while show you the different part of the water electrolyzer and how the catalyst will be coated, and how the membrane electrode assembly is there for producing higher pressure hydrogen. Okay. Today's lecture, we'll discuss a bit of storage method, and some portions will be covered here for the transportations part. Okay. As you aware that this is the week number 10 live session. Okay. So I will do today. I'm just start with initially I will start. Generally, I do some explanations of slides, but today I will start with the MCQ questions. Okay. Okay. The first questions. The first questions is The entropy of mixing for a high entropy alloy can be calculated using which formula? I mean, what the question is asking, you have to remember the formula. I am not going into details, but what the fundamental behind these questions? The questions is asking that when you will mix the two or more metal, I mean it is called alloy. This is the first, this is the second, or this is the third, fourth, fifth. Okay. This is the complex metal hydride or complex alloy. Why we are mixing? Because the mixing is done obviously just to increase the entropy. Increase the entropy. Okay, just you wait. Students is coming. Why this is the mixing is done? Just to make sure that entropy will be higher. Why the entropy will be higher? In the last, uh, any one of you asked me one questions that why we will prefer the higher entropy? Delta S will be higher. Delta S, this is the delta S will be higher. Entropy changes will be higher. And enthalpy, delta H should be lower. Am I right? For hydrogen storage system, for hydrogen metal hydride or complex metal hydride systems. Is it right? Is it okay? Okay. So why the enthalpy should be lower for the complex hydride or metal hydride systems? The enthalpy should be lower because if I make one systems or if I made one storage systems, still now the students is coming. Okay, why the enthalpy should be higher? So why the enthalpy should be lower? Because for any systems like metal hydride, this is the metal. When the hydrogen will be absorbed, because you know that the metal hydride systems is a absorbance phenomena because here it is a bulk phenomena. The hydrogen will be penetrated. At first, hydrogen will get separated into two atom, and this atom will penetrate through the bulk of the metal, and then it will absorb in the metal site, and it will form metal hydride. Okay, this during the absorption systems, and during the release of the hydrogen from the metal hydride, just to from the metal, it will require some externally heat. Okay, external heat just to bond dissociations. Hydrogen will be dissociated from the metal hydride, such that hydrogen will be formations will be there, and hydrogen gas will coming out. What amount of energy you have to supply? That is, if the lower amount of the energy will supply to the metal hydride just to release the hydrogen, it is the better choice. But it is never we want that higher amount of the energy will input for releasing hydrogen from the metal side. That's why the hydrogen bonding with the metal, this energy binding should be lower. So enthalpy should be lower. Okay. And but entropy should be higher. Actually, what happened? Every natural systems or natural reactions or anything for the systems, the entropy will rise. Okay, entropy will rise. It is a spontaneous process. Okay, if the entropy is automatically rise, that means it is a spontaneous process. Okay, that means Earth is rotating around the sun, or water is flowing. This is the natural process. That means in every systems entropy is increasing. Okay, this is the dq by t. dq by t. It should be greater than every systems. It should be greater than or equals to 0. Okay, that means spontaneous process. But for the reversible process, you have to put something such that entropy will not be high. Okay, so just keep in mind for the any natural processes entropy will be high, and for here the high amount of the entropy, that means the it is a natural process. I mean less amount of the bond energy or less amount of the energy you have to supply to the metal hydride to release the hydrogen. Okay, so our questions is that for high entropy alloy can be calculated using which formula? For the mixing of the 1, 2, 3 or more metal, the formula is which one will be correct? Here delta S mixing equals to minus of R I to N, how much number of the metal is associated in the to form the alloy, and the C1 LNCI. Here this is just eliminating R, and this is here no C, and which options will be right? If you see the slide, you can give the answer. The proper formula will be this one, the first one. Okay. Next questions. A high entropy alloy should have minimum how many elements? Okay, I have forgot to cover this answer. You have gone through the slides, I think. There are the minimum number of the metal to form a high entropy alloy. There is 5. Okay, and the concentration should be more than 5%, 5 weight percentage, 5 weight percentage. Okay, I mean suppose A, B, C, D, E, the 5 metal will combine together. They will make one alloy, high entropy alloy. Every material should have more than 5 weight percentage content. Then only we can say that it is with 5 metal element. It is called high entropy alloy. Okay. Which method are not used for producing hydrogen from NH3 BH3 ammonia borate? Okay. Which method are not used for producing hydrogen from ammonia borate? Which method? Thermolysis. What is the process of thermolysis? This is the process of reacting with water. Reacting with water. This is called thermolysis and producing hydrogen and subsequently other element, other compound. This is called thermolysis. Sorry, this is called hydrolysis. I mean water. And thermolysis is giving some heat. This is the heat. Okay. The heat will be supplied to the any metal hydride or metal complex hydride or high entropy alloy. Then the hydrogen will be produced. Okay. So this is okay. These are used for producing hydrogen. Okay. Chemisorption. What is this process? This is the process of splitting the hydrogen. When in metal hydride, the hydrogen molecule will come and they will split into two atom of two hydrogen atom. This is process is called chemisorption. So our answer will be C. So our answer will be C. Okay. Dehydrocoupling. That means this is the combinations of the heat and water. Okay. They are also used to produce the hydrogen or releasing the hydrogen from the any complex or metal complex. Okay. Next, the question number 4. Compute the capital cost for liquefied hydrogen production for here are given value C equals to 0.5 metric ton per day, N equals to 3 and I equals to 1.6. What is the C? C is the liquefier design capacity. Okay. It is given that the capacity is liquefier given capacity is 0.5 metric ton per day. This is the capacity. C is the liquefied design capacity. And what is the N? N is the number of the liquefiers. Number of liquefiers. How many liquefiers were used to liquefied hydrogen gas into liquid hydrogen? Okay, this is called the liquefier. The liquefier. It is given that N equals to 3 and C is given 0.5 metric ton per day and I. What is I? I is plant cost index. Okay. Okay, okay, just wait. Okay, the plant cost index is given as I equals to 1.16. 1.16. Okay, you have studied the formula of capital cost of liquefied hydrogen productions. If the plant capacity is like zero point 0.5 metric ton per day or million ton per day. Okay, so our cost formula is like this: cost equals to n multiply, this is the formula I am writing. This is the formula you have to remember for calculating such type of questions, or if the such type of questions will come, you have to remember the formula. C to the power 0.8 multiply I. If you put the value of number of the liquefiers in one plant, total number of the liquefier is here 3, and 5.6 into C, a design capacity 0.5, 0.5 to the power 0.8. I, cost index, this is the associated with the plant design. It is actually something relative term. Okay, this will vary for from plant to plant. Okay, so it will come like uh, the value will be like this. Okay, okay, so this is in term, normal term, and if we calculate it into million, then 10 lakhs equals to 1 million. So it will be like 11.2 million US dollar USD. So our answer will be D. Okay. Next questions. Question number 5. Calculate the cost of ZrCr2 in USD per kg such that the cost of Zr 96 USD per kg and chromium Cr 50 USD per kg. This is a very simple numerical, like 5 or 6 class students. So you have to. I have seen one big formula is there, but you have not remember this big type of formula. Just you, from your basic understandings, you can calculate this formula, or you can calculate the cost value, cost estimation. Okay. Uh, okay. What are given? Okay. The cost of 1 kg Zr Cr2. Okay. The question is asking cost of cost of 1 kg Zr Cr2. 1 kg Zed Cr2 means that 1000 gram. Okay, I am converting into gram because the molecular weight of any element, the standard is in given in gram. Okay, so first of all, you have to calculate what is the molecular weight of ZrCr2. Before that, you have to know the molecular weight of Zr and Cr2. So molecular weight of Zr, okay, equals to, you can search from internet also, that is the 91.22, 91.22. This is the molecular weight. That means this is the gram per mole. Okay, and molecular weight of Cr, chromium, is 51.99 gram per mole. Okay, so total molecular weight of ZrCr2. So ZrCr2 molecular weight will be calculated, molecular weight ZrCr2 molecular weight will be like this. Zr, nah, Zr, it will be 91.22 plus Cr2 51.99 multiply 2, as the two atomic atom is there, chromium atom. So it will coming that 467 467 467.31 gram. Okay, so molecular weight of ZrCr2 is 467.31 gram. It's okay, but our question is asking that 1000 gram or 1 kg of Zr to CO3. What is the cost value? Okay, okay. So how many moles? So then you have to calculate how many mole, how many moles of ZrCr2, ZrCr2. It is very simple that just you divided it 1000 divided by this much 1 mole molecular weight. So 467.31, the number of the mole will coming that it will be like 5.12. Okay, 5.12, 5.12, 5.12 mole of ZrCr2. The question is asking that 5.12 mole of ZrCr2 metal cost. Okay, so now we are going for cost estimations. It is given that 96 US dollar per kg, means that 1 kg Zr cost is 96 US dollar. So you can write the cost estimations. I am taking different color.
How you will you get this 467.31? Because 91.22 plus 51 is almost around 200.
Okay. This is not. This is 195.2. This is 195.2. This is 195.2. It will coming 195.2. Yeah, this is gram. And if we calculate, if we divide it by 195.2, then it will come in 5.12. Sorry, 190, 195.2. Okay. Now it is okay. This number of the mole. Okay. Now this is okay. Okay. Now coming for the cost estimations, coming for the cost estimations, here it is given that for Zedder, 1 kg Zedder, 1 kg Zedder, it is given 96 USD, 96 USD. So for how much amount of the Zedder is required to form 5.12 molar Zedder Cr2. Okay. For that calculations, or in another word, you can say that the Zedder
Same,
cost will be Zedder
same,
cost.
same mole of jade, same
Yeah.
mole
Huh.
of chromium.
Huh.
Because
Zedder cost will be 5.12 5.12 multiply Zedder molecular weight, that is 91.22, this much gram, multiply this is the in gram. Okay. So total Zedder is required this much amount of the gram. So it is coming the 467. This is not actually, this is another thing. 467.31 gram Zedder is required to form 5.12 mole Zedder Cr2. Okay. So it is given that 1 kg of Zedder is cost 96. So 467.31 gram Zedder is cost will be, it is simple that 96 divided by 1000 gram multiply 467.31. The cost will come that 44.86 USD. This is the all about the Zedder calculations. And next is the Cr, chromium. For that chromium, total gram of chromium required to make 5.12 mole Zedder Cr2, chromium requirement is like this: 5.2 mole chromium Cr, 5.2 mole Cr2. So 5.12 multiply chromium molecular weight is 96. There are two molecules. So if we calculate this, it is coming 532, 532, 532.37, 37
so
gram.
from where we get 96, sorry,
96 is the molecular weight of Cr. I mean atomic weight of Cr. Sorry,
but
this is not.
51.99 you mentioned above.
Uh, uh, uh.
51.99 is a molecular weight of chromium.
Okay, okay. Not 96. This is 51, 51.99.
We can straightforward see the ratio of the moles and then also we can calculate.
Okay,
Correct.
you can
Correct. And
you can
also that mole is not required to calculate, right?
yeah, you can calculate, but you should understand the basic thing.
Yes.
That's why I am explaining, because this type of questions, this type of mole calculations, for any calculating the reactions, for any how many moles, millimoles calculations, reactions, you should understand. That's why I am elaborating it, because sometimes this is required for us also. Okay, this is 51.99. Okay, so this value will come. Okay, so this value, chromium, this much up amount of the chromium cost will be, cost you can calculate that chromium cost is 50 USD per kg, means 100 gram of chromium cost is 50 USD. So this much of gram of chromium cost will be, this is like 50 multiply 532 532.37 divided by 1000, it will coming around 26.61. There is one formula ma'am has already displayed in her PPT slide, but this is the basic thing of calculating any mole to mass, mass to mole, and for any reaction, for any molecular weight calculations. Okay, this is required. That's why you should understand. The basic is this much USD. So if we add these two, chromium cost and the ZR cost, it will coming around, uh, it will coming around how much? 71.47. I mean 71.5. Okay. So our option is B. Okay. Just you go through the process how I am calculating, but you have also your own technique for calculating. Maybe you can use this formula, or maybe you can use from your own theory or own
There is
observations.
one
Okay.
question that in the exam,
Yeah.
whether this molar weight would be available or it has to be remembered.
Actually, for calculating the such type of questions, you have to remember the atomic weight. Okay, for remembering the atomic weight, you have to know the. It is very difficult to remember this atomic weight of every molecule, every element. So obviously, I think the in the questions it should be provided. The atomic weight should be provided. Otherwise, I'm not. I don't know the what is the Zeta atomic weight. But some of the students from the chemistry background, they can remember, or they may be remembered, or they may be much more familiar with the all the atomic weight, all the things. But generally, in general, it will be provided. Okay, but just you here just learn the technique how I am calculating, how you will calculate. Okay, till now. Okay, this is the things. Which technique is used for inspections of hydrogen transportations pipeline? The questions here is the inspections of the hydrogen transportation pipeline. You have studied the hydrogen can be transported through the pipeline, or through the pipe. It's maybe compressed hydrogen gas may be transported. It may be liquid hydrogen may be transported through pipeline. Okay, there are the different terms and conditions for this much of distance. You have to use, you will use the liquid hydrogen for this much. If the distance will be high, the distance will be low, you can use the gaseous hydrogen. or you can use different conditions is there. But the questions is from the inspections related, but the inspection is a very important part, because you know that hydrogen gas molecules have larger diffusivity during the flowing inside the pipeline. Hydrogen gas may diffuse. Okay, when the hydrogen gas will be diffuse, the five material, if the material will not up to the mark, or there may be some problem, or maybe formations of the hydrogen embrittlement of metal, maybe some corrosions of gas pipeline is there. So inspections is very important. So maintenance cost is very high for carrying the hydrogen through the pipeline. Okay, the initial capital cost is high for laying down the pipe or for installing the pipe, but maintenance cost is also very high for different locations for some distance. There will be some pressure gauge, temperature, and all the sensing, all the instruments will be there, such that you can sense there is no problem, or where the problem will be there, you can detect the problem. So inspections of the hydrogen pipeline is very important. uh, can you remember the technique? Which answer will be right? Carbon isotropy will be used for which process? Do you know? Carbon isotropy process. This is also one technique to measure the age of any material. I mean, how old this material is. Okay, suppose this is thousands of year old. Some material
Carbon
is
dating.
carbon dating. Exactly. Okay, you can study from internet also. Electrical resistance tomography, as it is, obviously it is electrical resistance. I mean, this sort of resistance, electrical resistance, you can measure. Seismic wave inversions, I think this is for the earthquake detections. You may search Google search. Okay, but pigging technique is used for inspections of the hydrogen transportation pipeline. It is also uh, it is in your PPT slide also. Okay, just remember this technique name. Okay. Question number 7. The magnitude of energy input required to transport.
What is the answer of that question? What is option? D.
Option
Okay.
option D. Option D. Option
Okay.
D. Uh, this is pigging technique. But you can Google search for more details. Okay.
Hmm.
The magnitude of energy input required to transport hydrogen is blank times higher as compared to natural gas. This is also something you have to remember actually. Okay. Answer will be 4. Okay. You will just remember. Okay. Uh, what the questions is asking here. Okay. You have to understand. The magnitude of energy input required to transport hydrogen dash time higher as compared to natural gas. The questions is asking how many times higher. Is it really higher? Why it is higher? Anyone of you can answer why it is here higher? The questions may ask it may be lower. Okay, I will say it is lower, but it is wrong. Why it is higher? Anyone of you?
Small molecule and safety reasons, leakage problem and safety problems. cost is more.
Yes, but the magnitude of the energy input required, that means,
Very light.
yes, this the density of hydrogen is very lighter than the natural gas. So this very lighter density gas, if you transfer from one place to another place, you have to you have to give
More
some you have to give some more energy to carry this lighter density of gas from one place to another places. That's why the questions is asking in that way. If you study in such a way, then only you can, this is 4 is okay, you can, okay, but you have to understand the main theory behind the questions. Okay. And you what is the density of the natural gas? Just you will check after the classes what is the density of the natural gas and the density of the hydrogen. Is it 4 times or it will vary? Okay, I mean it will come near 4 times. That's why this 4 is answer. Okay. In terms of blending hydrogen with natural gas, what would be the impact at end use? The gas volume required to meet energy demand will be reduced. Gas volume required to meet the energy demand will increase. High volumetric energy density can be accomplished. And the reduced infrastructure cost. What is the question is asking here? The blending of the hydrogen with the natural gas. This is one easy way for hydrogen carrying through the gas pipeline. It is the blending of the hydrogen gas with the natural gas. Okay, this is the pipeline. This is the blending of hydrogen gas with the natural gas. Okay, CNG. The output end user applications, it's maybe the the user may use the combinations of hydrogen and CNG. The user may require the separate gas. Okay, maybe they required hydrogen gas separately and CNG separately for different applications. Okay, these are the questions. On what basis the demand rate will or impact, the demand impact will be there? Okay, so volume is a major parameter. Okay, because generally the end user demand such amount of the such liter of petrol, diesel or natural gas, okay, required. Okay, so the first answer is the gas volume required to meet energy demand will be reduced. Thus gas volume required to meet energy demand will be increased. So our answer will be gas volume required to meet energy demand will be increased. Means for the end user, if they take a mixture of the hydrogen and CNG, they have to take or they have to buy higher gas volume to meet that particular energy. Okay, as hydrogen gas is lighter, density is lighter. Okay, so our answer will be B. Okay, uh, the factor, what is the factor of safety taken for carbon fiber based composite vessel? The carbon fiber has very high strength. Okay, for any high precious tank or any high quality high strength tank, they uses carbon fiber composite. Okay, you just remember these things. Okay, carbon fiber composite has a very high strength. Okay, So what is the factor uses? The factor is 2.35. This is the 2.35. If I use only steel material, steel, so the factor will be high or low? Factor of safety
More high.
more. Why?
Because I already learned because as comparison to carbon fiber, uh, there is type 1, type 2, type 3, type 4. So there is more lighter but more safe.
Pressure withstanding
Uh,
capacity.
No.
steel can be bear less, I think so, in comparison with the carbon fiber.
Okay. Factor. What is the factor of safety? First of all, you should understand.
As a tank is designed with strength of that double or 2.35 times the capacity.
Exactly. So, the definitions of the factor of safety is permissible strength or allowable strength. I am writing permissible strength, permissible strength of material divided by exact material strength. Okay, or a material strength or yield strength. Okay, yield strength. Actually, technical word yield yield strength. Yield strength. What is the yield strength? Yield strength is the when one material is there, you are giving some pull to the material at which point, at which strength, or at which megapascal, okay, the material start to break or material start to yielding. That is the yield strength. Start to yielding means that the start forming necking formations will be there. I mean material deformations will be there. Okay. So generally what is desirable, we will not design the tank at that value. We will always keep some higher value for the design purpose. Okay. Because we will not go at the exact value of yield strength. If we go exact value of yield strength, then you have to, I mean, you have to keep some factor, you have to keep some safety assurance. Such that suppose your water tank capacity of your home is 10 kg, but you will not fill 10 kg, you will put 8 kg. So there is the factor of safety will be 2. This is also like this. We will not go at high strength. We will give some, we will go up to a lower strength level. So if you calculate this factor of safety in the design purpose, this will enhance from the factor of safety. Actually, tank dimension, tank thickness, design of the material or design of the tank will be there. Design of the tank will be there means that the design of tank diameter, tank thickness, these are the all the things we will calculate it. If we put factor of safety more than one, obviously factor of safety will be more than one. Okay, one question is also there, factor of safety will be more than one, less than one. The factor of safety for any designing, it is greater than one. Okay, because less than one means that the material will fail, your design will be more thinner, I mean less diameter or less thickness. Okay, so factor of safety should be higher than the one. So design will be in terms of thickness, thickness thickness of the tank, diameter of the tank, length of the tank, this much. If we put the factor of safety more than one, the thickness of the tank will be higher value thickness of the tank. If you do not put factor of safety in your design calculations, then suppose thickness will is coming 10 mm. If we put the factor of safety more than one here like 2.3, this 10 mm will be coming like 15 mm or 12 mm. If your tank thickness will be higher, then that means you are putting some more extra safety. Okay, that means you are giving some factor of safety to your tank during the design time. So for the carbon fiber, this factor of safety, okay, you have to take this value. You have to remember actually. Question number 10: refilling the nozzle in the
Sir,
exactly.
so in case of steel, the factor of safety will be lesser than the carbon fiber, isn't it?
No. Factor of safety for the steel will be higher for getting 50 mm thickness, for getting 50 mm thickness.
Okay.
Okay, because at first you have to understand higher thickness of tank means there is more safety. Okay, okay.
But
So
depends
that we
upon
understand, but
that upon the
compared to
materials.
Huh. How the
compared
design?
to the
Yeah.
compared
Okay.
compared to the material we are so
Yeah. Okay.
carbon
Just I.
fiber
Uh,
carbon
yeah, I am coming to that point. Okay. Just if you will understand
fiber
one thing, then it will be
and
clear.
the
Okay, I understand your
steel.
questions. Okay, I understand your questions.
Okay.
This is the basic things of every
So
engineer.
in
I understand. Just
if we compare
okay.
factor of safety of both,
Uh,
then which
okay, just to see
one
what
will
I am. Okay, just to see.
be higher?
Just to see one thing, then only you can understand what do you mean by design. Design of tank, design of building, design of bridge, design of road. Okay, that means why it is not writing. 1 minute. 1 minute. A designing of building means designing of building means or designing of bridge. Okay, designing of it is not written. Wait. Okay.
So
Okay. Okay. Just okay. Design of any building or any column structure or any bridge means that you are given one material, suppose steel. The pen is not working.
uh,
Okay.
yes,
One is steel. This is
yes,
material
the
A, and B is carbon fiber.
Asimji, your voice is disconnecting. We cannot hear you. Might be you in mobile.
No. My internet is connected
No,
through
no,
Wi-Fi.
not. They Asimji want to say something, but their voice is
Oh,
dis-
okay. Just I am explaining. You can understand it is easily. This is carbon fiber. There are two material carbon fiber. You are going to design one tank or building any road. Okay, that means suppose for the tank. Okay, for the design of the tank. Suppose steel has a strength like uh, 76,000 megapascal per. Suppose I am taking it as a 10. Suppose steel has a strength of 10, any megapascal. Okay. Suppose carbon fiber has strength. This is the in megapascal actually. Megapascal. Megapascal. Megapascal means you know that Pascal unit the Newton per meter square. This is the Pascal. Okay. Newton per meter square. Suppose carbon fiber have higher strength. So you can take as is 20 megapascal. Okay. So and your tank, suppose you are designing one tank. Suppose you are designing one tank. That means suppose you are designing one tank with steel material. Okay. So you have to calculate how much the diameter should be, the thickness should be. Okay. For the designing case, what is there? That is the stress equals to stress equals to stress equals to this is the load by area. Load by area. Load by area. What is the strength of steel here? If you put that no, oh no. Suppose okay. If you put 10, if you put 10 for the steel, for any constant, for any certain load, suppose x, load is your fixed. Load is your fixed. So you can calculate the area. Area means what will be the diameter and the thickness, all the things. I mean B into D. You can have some dimensions, okay, or thickness. You can calculate some thickness, okay. It is okay. For the load, load is fixed. For the 10, the area will be, suppose your thickness is coming, suppose your area is coming 5, area is coming 5. But when the, if you calculate the carbon fiber, that means your load is x and this is the area and this is the 20. Your area, what will be your area? The area will be higher. Area will be higher. Suppose it is 7. Okay. This is the material strength. Okay. So for the, but factor of safety, this is the material. So factor of safety, but we are not giving to the same value of or in terms of no, or in another terms, okay, or another terms, if we use the area is fixed, your load will be vary. Okay. For that case, carbon fiber, for that case, your area will be fixed or dimension will be fixed. This will carry less load. This is less. This is higher amount of the load. This is the higher amount of the load. This is the higher amount of the load. So this higher amount of the load, we know that the carbon fiber can carry higher amount of the load for a given area or for a given thickness or for a given dimensions. So for that case, factor of safety will not take larger because carbon fiber already has higher strength. We do not require for the higher, but for the steel the load will be less. For that case, a factor of safety should be higher to match that value, or to assure that this much of amount of the load it can carry with that same dimensions of the tank. Okay. uh, Anyone of you from the mechanical or civil background? Then such type of calculations or such type of designing part is coming. Okay. For higher strength material, the factor of safety will be lower, and the lower strength material factor of safety will be higher, because there is a chance of high failure of the low strength material, and there is a less chance failure for the high strength material. Like carbon fiber has a lower factor of safety because the chance of failure is very very low. That's why we have not so much concern of factor of safety. Well, we have to take little concern for the high strength material. Already it is very, I know it has very, uh, it will not fail. Okay. Next questions. Next question is, a refueling nozzle in dispenser are built upon which standard? Okay. Uh,
We have to remember all standards for cylinder or tank, nozzle, pipe. There are so many standards in there.
there are no.
Sensor.
There are four standard. One is dispenser standard. One
Mhm.
is dispenser material standard, and another one is the nozzle standard. Okay. A nozzle and dispenser is, I think, same. Okay.
Yes.
And another one is the liquefier, uh, standard, or another one is the another one. This is the distributor pipeline standard. Okay. So there are three standard you have to remember. Okay. Just I am coming to the PPT slide. Okay, you can understand. Okay. For the dispenser, I mean, you have seen the dispenser in the refueling stations like petrol diesel refueling stations. Okay, that is some they are holding this brake type dispenser, and nozzle, from the nozzle it will coming. Okay. And from the dispenser, all the, what is the dispenser? The dispenser is the controller. They are putting the temperature, pressure, they will see all the things. Okay. So the standard, this is the SAE J2799, is a standard specific the hardware and software requirements for communicating with hydrogen surface vehicle
We
at
cannot
fueling
see. We
stations.
cannot see screen actually.
Huh?
Please share your PPT. We cannot see.
Okay. It is already shared na?
Okay, let me check. What I cannot see. Somebody can tell. Who one can see.
Yes, it is visible.
I
Okay.
think you just disconnect and rejoin.
Yeah, but I can see you. But I
Okay.
cannot see PPT.
Okay. I think you have to rejoin it.
Okay.
Okay. Next time coming, some of the important slide I will go through. Okay. What is the main purpose of these things, that is the generations of the hydrogen is costly, and as well as storing of hydrogen is also very very costly. So we will not focus only on generations of the hydrogen. We have to focus on storage systems also, because there is a fluctuations of the supply demand. So the hydrogen should be stored for the future applications or future purpose. So and there are different challenges for storing the hydrogen. That's why we are studying the hydrogen storage material or hydrogen storage systems. Okay. Okay. So that's why we are that's why we have to study the hydrogen, how the hydrogen can be stored in a lesser cost, lesser value. Okay. Uh, I will just point out the main basic important things. Okay. Okay. Complex hydride. The complex hydride. What is the complex hydride? The complex hydride. Complex hydride. Why we are interested for complex hydride rather than metal hydride? Can anyone say why we are interested in complex hydride?
More storage.
Huh. More storage means that the
That
high
means,
gravimetric storage and high
yeah,
volumetric
yeah.
capacity.
Percentage weight of hydrogen we
Yeah.
can get more hydrogen. Yeah.
Huh. For the metal hydride, for the metal hydride, the suppose 1 kg of metal hydride, the hydrogen can be stored. 2 kg of hydrogen can be stored in 1 kg of metal hydride or 1 kg of metal. This is metal hydride. But suppose for the complex hydride, if you form one complex hydride, how the complex hydride will be differ from the metal hydride, I will explaining. But for the complex hydride, suppose 1 kg of complex hydride, it can store 4 kg of 4 kg of hydrogen. Okay. So gravimetric capacity of metal complex hydride is high than the metal hydride. That's why the complex hydride is very very targeting research or targeting field for higher for storing higher amount of the hydrogen. Okay. How the complex hydride will form? The metal hydride, you know that there is a metal. Okay. And it will react with the metal side. The metal side I explain by using the tetragonal side. In the tetragonal side, the phase is there. In between the phase, the hydrogen atom will be there, absorb. Okay. This was the case of the metal hydride. Okay. In the last classes, I think. Okay. But here the complex hydride is also formed with the metal. But here what happened? Here one thing is the XH. This is the symbol of the complex hydride. This is like this. After writing sometime, it is the pen is not working. I don't know. This is the X H N M. This hydrogen is, that means you can say hydride. Hydrogen means it will be hydride. Okay, metal hydride or complex hydride. This is the hydrogen, you know. This X may be metal or X may be non-metal. This may be metal, maybe non-metal. Okay, this will react with the hydrogen to form the hydride. The bond will be covalent bond. Okay, covalently connected. And there is another metal. There is another metal, and this covalent form, this is this is anionic. This is anionic. This is anion, anion. This is anion, and this metal is cation. Okay, cation means what is the means of anion and cation? Yeah, cation. Anion means negative, and cation means positive or plus charge. And this anion and cation combine together, and this complex hydride will form. Okay, this is the ionic bond with the metal. This is how the complex hydride will form. The different classes of complex hydride: alanates, borohydride, amides, imides. Alanates means there will be Al. Sodium alanate means NaL. So the alumina AlH4, this is anion, and Na plus is the cation. It is forming the sodium alanate. How this sodium alanate will produce hydrogen? When we'll heat, when we'll give some heating to this alanates or metal complex hydride, this will react or this will dissociate hydrogen. Okay, my pen is not working. Okay, so when we'll raise the temperature of this alanate or such kinds of thing, the hydrogen will be generated, or you can get hydrogen, and different metal will remain after reactions. Okay, this is alanates, means aluminium is there. Aluminium will be covalent with the hydrogen. Okay, borohydrides, there is a boron. Okay, sodium borohydride, there is a sodium, boron, and hydrogen. This will form complex hydride, borohydride. You can study ammonia boron. Here is the hydrolysis process. This is the hydrolysis process. We will add ammonia boron, and we will add water, and the hydrogen will be formed. Okay, this is the hydrolysis process. So you can see that this ammonia boron has a very high gravimetry hydrogen storage capacity. Okay, liquid hydrogen, CNT storage, LiBH4, NH3BH4 is a higher gravimetric weight. Means that the higher amount of the hydrogen can be stored in a small weight of complex metal hydride. The hollow glass microsphere for hydrogen storage. This is the design is this like this. This is also porous. This is the porous material, and in between there is the hollow. Through the porous, through the pore, the hydrogen will come and it will store inside the sphere. And how this is formed, how this hollow particle will be formed? This hollow particle will be formed by using flame spraying method. Okay. And they uses laboratory glass frit. Okay. Glass frit means glass particle. Okay. Porous glass frit means actually this is the porous material. Okay. Frit means porous. Any types of I will also use this term when the electrolyzer assembly is there is a titanium frit, that means porous titanium plate, okay, or porous titanium sheet is called frit. As it is porous material, so hydrogen can be go inside the sphere, okay, and it has a very high capacity of hydrogen storage, okay, through the hollow glass microsphere. Why they are so important? Because they are non-toxic, lighter weight, okay, environmental friendly, low cost, okay, reusable, durable, okay, high mechanical strength, high hydrogen mass density, and safety non-explosive. That's why they are important, and that's why the some trend is there for exploring this type of material. Okay, this is all the things how the hydrogen storing material solid in solid state corresponding to their gravimetric capacity. Okay, you can see. Okay, this is important. Preliminary high amount of the hydrogen storage or high capacity hydrogen storage, the geological storage will be preferred. Okay, for higher amount of the hydrogen storage, the geological storage will be preferred. Geological storage, that means it may be water aquifers, it may be depleted oil and gas reservoir, it may be salt caverns. Okay, so these are the use basically for the high amount of the hydrogen storage. Okay, but there are some sort of disadvantages like salt caverns. They cannot be used for the longer period of time. Okay, if you consider the time period, hydrogen is a very high diffusivity molecules, it can diffuse easily. So for the salt caverns, the hydrogen cannot be, you cannot be store hydrogen for a longer period of time. So when we will consider, so for storing hydrogen you have to consider how much time you will store time. You have to consider the time period for storing of hydrogen and quantity of the hydrogen, how much amount of the hydrogen you are going to store. Okay, quantity of the hydrogen, and you have to also consider the cost of the hydrogen, obviously.
Maybe transportation.
Huh.
how
There
much
are
how much
ha,
distance
ha,
from the source or an application.
source and applications. So supply and demand relationships you have to remember. Supply and demand relationships. Supply and demand relationships. So by considering this time period, how much time you are going to store hydrogen, how much quantity of the hydrogen store, you have to choose the different storage options. Not that you are storing only 1 kg. I am giving one example. You are storing 1 kg of hydrogen, that you want to store this 1 kg of hydrogen by using the geological storage. I mean salt cavern. You will put 1 kg of hydrogen inside the earth atmosphere, earth crust. And 1 kg of hydrogen, it is not feasible actually. For 1 kg of hydrogen, you have to store one tank. Okay, one tank means, but the tank material should be, which type of tank you have to use? Type 4 tank you have to use. In type 4 tank, what are the design considerations they have taken in type 4 tank? They have taken, there are two layer inside, the one polymeric, high strength polymeric layer, and the outer layer is the metal layer, and in between there is the gap. This gap is filled with insulating material. Do you remember insulating material? And there are the hooping material. The hooping material is covered, fully covered. This is called the type 4 tank. Okay, so according to your consider, but you are storing tons of hydrogen, but you will not store into the tank, or you will not store into the reservoir. You have to go for the geological storage, salt cavern storage, depleted oil and gas reservoir, this type of storage. Because if you made the larger amount of the tank or higher sizes of the tank, the cost will be very high. Then you have to go for the geological storage. So you have to think about the, and how much time you want to store. Suppose efficiency of the tank storing efficiency is very high. Okay, but geological store, salt cavern storage, the efficiency is not so much high actually. Because it may be, the leakage will be there, and some depleted oil gas reservoir, there are some, the oil and gas will mix with the hydrogen. So then again you have to separate the hydrogen from the oil and gas. So you have to considering all the things, you have to choose the hydrogen storing option. That is the main concern. Okay, and sometimes you have to store hydrogen in a compressed gaseous form, or sometimes you have to uh, cryo based hydrogen storage, I mean liquid hydrogen storing. Okay, these things you have to consider. Okay, and these things you can remember, you have to remember that BOP. What is BOP? Balance of plant. What is the BOP? Anyone of you? This term is regularly used for, or in industry. Balance of plant means, for storing, I have written this. I have written this definition. Balance of plant is a term used in, not power engineering, in every industry sector or power engineering, to describe the auxiliary systems or component that support a power plant energy productions. Here also, for the hydrogen storage, for storing the hydrogen, you require different valve to operate. You require different motor drive. Okay, you require different compressor to drive. Okay, so you have to accumulate, you have to combine all the cost for storing the hydrogen. Then only you can say that for storing 1 kg of hydrogen, the cost is this much of amount. Okay. So BOP is very, very important. So I mean, you have to consider hydrogen storage cost is very high, or because you have to consider all the things starting from different maintenance cost, valve operating cost, and all the things you have to take taken into considerations. Okay. Okay. These things I have to explain a bit. When the hydrogen will flow, when hydrogen will flow from one point of pipeline to another part of the pipeline, the hydrogen will flow. Obviously, there should be some pressure difference. Then only the hydrogen will flow from one point to another point. So the gas will flow or water will flow from higher pressure to lower pressure. So positions 1 pressure should be high than the pressure 2. Then only hydrogen can flow. So this higher pressure is generated by using the compressor. By using the compressor. When the gas will flow through the pipeline, there will be pressure loss. How the pressure losses will there? Because due to the friction. Okay, pressure loss due to the frictions, or pressure losses due to the elbows, pressure losses due to the branching, and pressure losses due to the control valves, pressure losses due to the roughness of the pipe, pressure losses due to the length of the pipe. Okay, roughness mean friction. So these are the factor for losing the pressure of hydrogen gas. Okay, so when you will supply hydrogen gas from point 1 to point 2, suppose in between midpoint the pressure is lost, the pressure is lost, and hydrogen will not flow. In midpoint you have to made one station on hydrogen and distribution stations. Okay, and there will be compressor machines, and it will compress again, and it will increase the pressure of the hydrogen, and thus the hydrogen will flow from this midpoint to point 2. So pressure is very important for transporting the hydrogen gas through the pipeline. So this is the one formula uh, of volumetric flow rate. Okay, this will depend pipe length, pipe diameter, difference in the elevations, gas flow rate, gas specific gravity, and compressibility factor. This all the factor will depend. This all the factor you have to needed for calculating the volumetric flow rate of hydrogen. Okay. Okay. The blending of hydrogen with natural gas. This is important. The blending of the hydrogen gas with natural gas means the combinations of the blend gas you can use directly, or you can separate the hydrogen from the natural gas. Why this concept is coming? Why this concept came? Because for hydrogen gas pipe, for hydrogen carrying the gas pipeline, you have to rebuild this pipeline through the for underground pipeline. But if you blend the hydrogen gas with the natural gas, then the simultaneously hydrogen gas and natural gas can be carried through the pipeline. Okay, but there is a some restrictions. Hello.
Do you mean no need to prepare dedicated pipeline for hydrogen
Ha,
because that will be costly?
ha. Uh, this is the again it will coming for the end using applications. How much quantity of the hydrogen is required? If the demand is very high, then we will go for one separate hydrogen pipeline. But the demand is very less, then why will go for the separate pipeline? What the existing systems is there, we will use these facilities. When the demand will be very high, suppose in the greater Noida region, the demand is very high for the hydrogen demand, then in this area we will deploy one separately hydrogen storage pipeline, because this blending hydrogen and natural gas will be there, then the hydrogen gas separations unit will be there, the cost of separating from hydrogen from the natural gas will be high. It will all depend on the requirement of your matlab demand requirement. Okay, but initially this may possible, this may this is possible thing. Okay, this is the possible option you have, you can do. Okay, so suppose you were planning for distributing the hydrogen. Okay, but initially what the planning should come, initially the your planning should come, initially your demand will be very less, so you can use the like Vodafone network, Idea network, Vodafone, Geo, Airtel network. What they are doing, they are sharing business. Suppose Vodafone has one tower at one locations, they have made by their own cost, utilizing their own cost installations one tower. Okay, they are fabricated one tower. The Airtel tower is also installed in that tower. Okay, so they are sharing their tower. Okay, so every places separate tower, no need for installing separate tower. Okay, one tower will be there and lots of microwave antenna will be installed in that tower. Okay, this is the way like this, but there is a challenges. uh, there is some specific amount of the hydrogen you can add, otherwise it will not effectively carry the hydrogen or natural gas, or blending of the hydrogen and natural gas. Okay, so blending above 50% more challenges, but you can keep it below 50% or 40%. Okay, in another case, if you increase the 50%, more than 50%, above 50%, so then you have to take care the pipeline material, pipeline safety, all the things you have to consider. Okay, but generally if we use less than 50% or less than 40%, it is okay with natural gas pipeline. Okay, it will all depend on the demand at the end. Okay, and this is the some example, and this is the cargo ship or ship carrying the hydrogen, compressed hydrogen. Okay, sorry, this is the liquid hydrogen. Okay, imported hydrogen offers to diversify energy imports, but for the very long distance carrying the hydrogen, this type of things is okay, very good. Okay, then that pipeline will not okay. Okay, then you have to go for this type of uh, hydrogen storage systems, or you have to uses this type of transportations by using the ship. Okay. For the case of the this type of things, the boil off is a major challenges, like hydrogen maybe boil off, the liquid hydrogen maybe boil off, and the reductions in the hydrogen gas, loss of hydrogen gas. Okay, you know the boil off, how the boil off will occur. Okay, at high temperature, the temperature will rise inside the liquid hydrogen. This liquid hydrogen will be vaporized, the pressure will be high. Okay, and for avoiding the boil off, you have studied that there will be some extra amount of the vacant space is there in the liquid hydrogen storage tank. Okay, such kinds of thing will be accommodated there. Okay. Whatever I was talking to you, that in the transmission pipeline, okay, the hydrogen will be compressed by using the compressor, okay, a compressor, and this compressed hydrogen will can be carried through the by inside the cylindrical tube, okay, cylindrical tube, but very higher amount of the hydrogen gas cannot be carried from one place to another place by using this, like a truck or fuel delivery systems. Okay, then you have to go for the pipeline. This is called tube trailer delivery. And this carbon fiber factor of safety, you can remember, 2.35. Strength is very high. Lower density, it is the density is also lesser. That means the weight will be lesser for for storing same amount of the hydrogen. Okay, that's why the carbon fiber composite is very promising material for making the hydrogen gas storage tank or hydrogen gas storage vessel. For the liquid hydrogen storage, for the liquid hydrogen storage tank, for the liquid hydrogen storage tank truck, if you huh, uh, if you want to carry this liquid hydrogen from
तुम कहाँ से जा रहे हो? हाँ, गाड़ी से लेके आया था। तुम्हारा कार लेके आया? पाठशाला चक जा रहा हो? नहीं, पाठशाला तो नहीं है, ये 52 जा रहा हो? नहीं, 52 मेट्रो स्टेशन तक जाऊंगा मैं। चलो मुझे वहां पर छोड़ दो, फिर वो बेटर रहेगा मेरे लिए।
for highly insulated cryogenic tank, for highly insulated cryogenic tank like 4000 kg steel tube trailer, it is okay for 4000 kilometer, but beyond the 4000 kilometer, if you want to place the hydrogen beyond the 4000 kilometer, I mean your distance of travel with liquid hydrogen tanker truck beyond the 4000 kilometer, it is not suitable for the cryogenic tanker truck. Because what is the problem? The problem is like boil off. For a long distance, the truck will move from 4000 kilometer, and it will started, the temperature will rise, the boil off will start. So for a certain distance, this liquid hydrogen tanker truck is useful, but beyond that distance, it is not useful. Okay, so the distance is also important, from which places to which places, from where to which places
Yeah,
you are.
Tanmay.
you are carrying or you are transporting hydrogen, the distance is also important. Okay, these are the all um, data from the different researcher. Okay, liquid hydrogen tank. These systems, liquid hydrogen systems, is like this transmissions pipeline, transmission pipeline, transmission pipeline, liquefier. This is the liquefier, and the liquid after liquefier, this is the cryogenic storage for pressurizing or for at high pressure loading of the loading bays. Okay.
मैं धीरे धीरे चलाता हूँ, धीरे धीरे मैं नया हूँ, जैसे भी चलो, मेरा ये टाइम बच जाएगा इसलिए, क्योंकि अभी अभी पता नहीं है, ऐसे नॉर्मल टाइम जो जहाँ जाता हूँ मेरा 1.5 घंटा लग जाता है।
अरे
तो
असीम
वो
जी
52 से घूम घूम के
असीम
मैं
जी
जाता
यू
हूँ
आर इन
फिर
स्पीकर,
ट्रैफिक से बचने के लिए।
असीम जी अनम्यूट।
Huh. Okay. This is all about the fueling stations. Whatever we are discussing about the these things, how the fueling stations works. This is important. Fueling stations means the hydrogen will be carried from somewhere else where the hydrogen is generated, the generation plant. It will be carried through the tube trailer or maybe pipeline. Okay, or maybe the pipeline. Then uh, it will store at very high pressure because there is a sudden volume of storing volume. So we have to store this hydrogen at higher pressure. Okay, by using the compressor we'll use. Suppose the hydrogen is delivered by the tube trailer, and this hydrogen will compress to the compressor, and this compressed hydrogen will stored in the refueling stations. It is actually underground storage. Okay, then one refrigeration unit is there just to cool down the hydrogen unit, because at a high, very high compressive compression, the hydrogen temperature will be rise up. Okay, but we want 20 Kelvin for liquid hydrogen storage. 20 Kelvin. So refrigeration unit is very essential for storing this hydrogen, or just before coming into the dispenser. Before coming into the dispenser, the refrigeration unit is there just to cool down the hydrogen, because if the refrigeration unit is not there, the during the filling of your car tank hydrogen, the temperature will rise up. If the temperature will rise up, it may be explosive. So just before the filling of the car hydrogen into your car, the refrigeration unit should be there. So it is very essential refrigeration unit. I mean, it will cool down the hydrogen gas molecule temperature just before the just before filling of hydrogen or in refueling stations. Okay, so this path is followed for hydrogen gas refueling stations. Okay, you have to remember this refueling systems. So there is a restrictions of 85 degree centigrade. You cannot go beyond the 85 degree centigrade maximum restrictions temperature. Okay. Okay. This is all about your hydrogen storage and transportations. Next class we'll see hydrogen transportations, more about the hydrogen transportations and safety. Okay, thank you.